Hello student, today we are here for understanding some important theorems on the topic circle, and this theorem is actually for the class 9th Cbse and Icse. So it is again a very much important theorem for the circles which help you to solve your numericals based on this particular theorem from your textbook. So after this theorem, we'll took some questions also. We'll take some questions also related with the theorem. So let's start. You know that this is a circle, and a circle, there is a center of the circle, and let us suppose the point is there. A is the point, B is the point, and C is the point. So A is called the exterior point of circle, B is called interior point of circle, and C is called a point on the circle. Point on the circle. Now, now see, again this is a circle and it is centered. There is a 2 point on a circle. So line join these 2 point of a circle is called chord. And you know, the longest chord of the circle is diameter, PQ. It's a diameter, and it is called the longest chord of circle. Hopefully you are going to understand. Now see, this AB is called arc. As it is the smaller, you know that this complete one revolution or circumference of the circle is called actually arc. Okay, so this is the smallest part of this arc, so you can say that AB is a minor arc. And this AB, see, this above, it is called the major arc. That means chord is divide the circle into the two part. One is called the minor arc, another is called the major arc. Now guys, the first theorem, that the equal chord of circle subtend equal angle on the center of circle. What is the meaning of this particular? Let us suppose it is a circle. This is the center of the circle, and C, A and B, this AB is a chord, and this PQ is another chord, and you have given that AB is equal to PQ. So whatever the angle sustained on the center by AB is the same sustained by the chord PQ on the center of circle. That means if these two chords are equal, so if this angle is X, it must be X. That means or you can say that, or if AB is equals to PQ, you have to prove that angle AOB must be equal to angle POQ. This you have to prove. Okay, dear. So for prove these theorems, you have to be idea about the congruency of triangle. Okay, so we are going to prove this theorem with the help of the congruency of triangle. Now see, I am taking the two triangle. In triangle, this is the first one. This is the second one. In triangle AOB and triangle POQ, AOB and POQ, see, OA is equals to OP. This OA is equals to OP. Why beta? Because these are the radius of circle. Similarly, OB is equals to OQ. It is again the radius of circle. And third one is AB is equals to PQ, and it is the chord, and it's given if they are equal. So you can say that therefore triangle AOB is congruent to triangle POQ by SSS rule or criteria, side rule. So by CPCT we can say that angle AOB should be equal to angle POQ. That is the required proof of this theorem. Hence, proof. Now guys, come on the next theorem. If chord subtend equal angle on the center of circle, then they are equal. That means it is just a converse of the first theorem. Okay, the previous one. This is the theorem number 2. That means in this particular theorem you have given that angle AOB is equals to angle POQ. This angle is equal to this one, and you have to prove that what? You have to prove that AB is equals to PQ. This you have to prove in that particular theorem. So guys, see how we can prove it. Again, in proof, we again apply the congruency rule of triangle. In triangle AOB and triangle POQ, this and this, AOB, POQ. Again, you can see that OA is equals to OP, since it is the radius of circle. Again, OB is equals to OQ. It's the same radius of circle. And next one is angle AOB is equals to angle POQ. It is given. So therefore triangle AOB is congruent to triangle POQ by side angle side rule. Therefore, by CPCT, you can say that AB equal to PQ. When the two triangles are congruent to each other, then we can relate equally by anything in two triangles. So, this we require to prove. Hence, prove. Now guys, come on the next theorem, third one. It is again a very much important theorem. Theorem says that if a perpendicular drawn from a center to the chord, it bisect the chord. See, what is the meaning of this particular? This is a circle and it is the center of the circle. Let us suppose it is a chord AB. Okay, and from the center there is a perpendicular drawn on the chord. Let us suppose it is OP. So you have to prove, that means you have given, what you have given, that OP is perpendicular to AB, and you have to prove that AP is equals to PB. That means OP bisect AB. Let's see how we can prove. So for prove this theorem, we need some constructions. What construction? Construction is just join OA and OB. Join OA and OB. Join OA. This I have going to join and OB. Got it here? Now see, now took the two triangle again. You have again the two triangle, and this theorem is again based on the congruency of triangle. So in triangle AOP and triangle POB. See, again OA is equals to OB, since OB, since it is radius, OA equal to OB, it is radius. Again OP is equals to OP, it is the common side in between these two triangles. OP is the common side, right? Now since OP is perpendicular on AB, so therefore angle APO is equals to angle BPO is equals to 90 degree. It's given. Okay, why it's given? Because OP is perpendicular to AB. So you can see there, this is the right angle, so opposite to the right angle is hypotenuse. So in these two triangles, one hypotenuse are equal and one side OP is equal as well. So we can say that triangle AOP is congruent to triangle POB by RHS rule, right angle hypotenuse side rule. Now see, so therefore by CPCT you can write, what you can write, AP equals to PB in these two triangles, and hence you can say that OP bisect AB. Hence proved. Hence proved. Hi guys, the fourth one, it's again a very much important. What is the theorem says? In any circle, angle subtended by an arc is double. The angle subtended it at any point on the remaining part of the circle. What is the meaning of this particular? Let us suppose this is a circle and this AB is arc. This AB is arc. Got it? This AB is arc. It is the center. So whatever this arc subtends the angle of the center is the double. The angle subtended by the any remaining part on the circle. Let us suppose this is the angle. This is point O, and now from the same arc we are going to draw this one more angle on the circle. This is the angle on the circle, this is the angle on the center. Okay, and O, and let us suppose it is C. So what you have to prove? You have to prove that angle AOB is double of angle ACB. That you have to prove. That means if this angle is x, this angle must be 2x. This is the theorem. Okay, on the same arc. On the same arc. So this is the arc, and whatever the angle drawn on that particular point, remaining part of the arc is always half of the angle measured on the center. Okay. Now see how can we prove this. So for proof, here is a construction again. What is the construction? Draw CO and extend it to D. Okay, like this. This is CO. This is CO. First we join the CO and extend it by CD. Okay, this we actually did. We just draw a line, join OC and extend it till D. Now you can see, now focus on this triangle first. In triangle see, in triangle COB, in triangle COB, you can see this angle is exterior angle of the triangle of COB. So can I write like angle BOD is equals to angle OCB plus angle CBO. Why? Because we know that, what we know that the exterior angle of triangle is the sum of opposite interior angle. Okay, so from this relation we can write like this. This is your number 1. Again see carefully in the same triangle COB, you can see carefully that OC is equals to OB, that is the radius. That means triangle COB is isosceles. Okay, because the two sides are equal, and hence you can say that angle OCB is equals to angle CBO, because these two sides are equal. So angle opposite to this side are equal in this triangle. This is equation number 2. Now see carefully the first and second. So from first and second, can we write like angle BOD is equals to angle OCB and plus angle OCB, because CBO is equals to OCB, and now angle BOD can be written as twice of angle OCB. This is the third one and important result. Now again similarly four triangle, this one second triangle, four triangle COA. This is again exterior angle of this particular triangle, so you can write like angle AOD is equals to twice of angle ACO. AOB, as in this triangle, in first we already proved that this angle BOD is twice of the angle OCB. Okay, similarly we can do like this, angle AOD is twice of angle ACO. Okay dear, this is your equation number 4. Now add 3 and 4, you get angle BOD plus angle AOD is equals to twice of angle right hand side of third, OCB plus right hand side of fourth, twice of angle ACO. You can see BOD plus AOD. This is BOD, AOD. So BOD plus AOD is completely the angle AOB. Is equals to, from these two twice common, angle OCB plus angle ACO. So angle AOB is equals to twice of, see, is equals to twice of, now see, OCB, yeah, it's a huge OCB, yes, OCB, right, OCB, sorry, it's right, and ACO, OCB and ACO, this whole angle is actually angle ACB, that you have to require. Okay, hence proof. Thank you guys. Hope you understand all these four theorems. These four theorems are very much important. After that, one more topic, more theorem from this exercise. This is the cyclic quadrilateral, and in the cyclic quadrilateral there is no theorems, and not need to do any kind of theorems. It's just the knowledge we'll share later on. Hopefully you enjoy the class. Thank you very much.